We have been talking about observability for a very long time, and we tend to think that it is a solved problem, and it is dashboards, logs, alerts. But as soon as AI enters the picture, as soon as AI agents enter the picture, they don't behave like traditional APIs do. They hallucinate, they cascade, and they fail in ways no alert was ever written for. Even for us humans, it's hard to figure out whether they fail or not. The answer seems to be in a unified approach, and that is what Snowflake is betting on when it comes to unified data and observability. And today we have with us Jeremy Burton, General Manager of the Observability Unit at Snowflake, to talk just about that. Jeremy, first of all, it's great to have you on the show.
Thanks for the invite. Appreciate it.
It is my pleasure. Now, let's just talk about observability as we have been seeing for years. Talk a bit about when it fails, when AI and AI agents enter the picture, and then you'll talk about the approach that Snowflake is taking to kind of fix this problem.
Yeah, as you mentioned, we've been looking at solving the observability problem for quite some period of time. And certainly when Observe got going, now obviously part of Snowflake, the big disruption was the move to microservices and distributed applications. And you had more components, you had more telemetry, and it made life a lot more difficult. I think AI and specifically AI agents, it's maybe not dissimilar to microservices in that they are discrete components doing work on the behalf of humans. And look, there could potentially be thousands, tens of thousands of these in one particular organization. So I would say number one, we may have seen an order of magnitude increase in telemetry over the last few years. I think that's going to continue because what we know is that with more distributed components, you therefore get more telemetry, you get more interactions that you need to track. And if scale, was a thing over the past few years, it's going to be even more of a thing over the next few years. So I'd say number one, you have to have an observability platform architected for scale. I don't just mean handling massive volumes of data, hundreds of terabytes a day. I think that's going to be quite commonplace. The economics of querying that data have got to be an order of magnitude better than what we've seen in the past. If you've got more data and you're going to run more queries, it stands to reason that the cost per query has to decrease over time. And so I think this new generation and observing AI agents is really going to test product architecture. It's going to test not just the ability to handle large volumes of data, it's going to test the ability to query it efficiently. So that's sort of what I think is really at first blush going to change with architectures.
Right. And as you were rightly talking about, it was microservices, containers, but AI agents kind of operate differently. Of course, they are stateful, right? They are, of course, unpredictable, and they interact with each other in a way that we cannot fully trace at times. And sometimes they will lie to you as well that they are talking to each other. It happens so many times. Can you talk about when you work with customers and other organizations where you have seen what actually breaks in the legacy observability architecture? If we can use the word legacy now in terms of observability, though all these technologies are so new, and what actually has to be rebuilt from scratch for these modern AI workloads or agents?
Yeah, I mean, I guess my rather simplistic view is that an agent is something which talks to an LLM as well as talks to a database. So I think there are some similarities between agents and microservices, but there are some profound differences. I think there will be code in agents. There will be that code will talk to databases as microservices did in days gone by. But the big new variable here is that they will also interact with an LLM. And so in the past, I think we've been used to like an agent not working is it's failed or not running, and so that's a monitoring problem. Is it working or not? And then the second thing would be, oh well, maybe the agent is running, or maybe the microservice is running, but it's failing in rather unusual way, or we're seeing a pattern of behavior that's unusual. And so we'd use observability tooling to find out why. And this was the big aha, going back, maybe 10 years. Hey, it's not enough to know whether something's running or not. We need to know why it's operating the way it's operating. I think with agents, it's actually another slight change here, because an agent can be running. It can be not giving an error, but it may just be giving you a slightly different answer than it was giving you last week, last month, last year. And so it's not broken. It's just giving you a slightly different answer, or behaving a slightly different way than it did in the past. And that, in some respects, is sort of the design point of an LLM. They're probabilistic systems, not deterministic. As the prompt changes, or the contextual data changes, they can give you slightly different answers, which again is maybe not an error per se, but could have quite a profound impact on the operation of your application. So I think in this new world, what we've also got to do from an observability standpoint is we've got to look at the prompt and response. We've got to run things like evals against these agents to understand how responses are drifting over time. And we've got to try to understand what is causing that response to drift. So yeah, in some ways, some of the things are going to be the same. Yeah, you're still going to have problems with code. You're still going to have problems with databases, but you've got this new sort of category of problems, which is, hey, it's behaving a little bit differently based on the inputs or the context we're providing. And so, hey, like what changed? Why is the answer drifting? And that is certainly a new problem domain that we've not seen in the past.
Right. I mean, that I'm a heavy user myself, and no matter how fine-tuned, refined you do the prompt engineering, the AI cloud has become very notorious these days. It doesn't just follow whatever, you have to remind it 10 times. That is the problem with those models. But let's talk about the architecture itself in this shift from traditional apps to AI-driven workloads. Which architectural components you folks have identified are becoming the bottleneck?
I think right now with sort of agentic AI applications, I still think it's very early days. I did a couple of customer dinners last week on the East Coast, and I'm not, in the middle of Silicon Valley where I am right now, where I think we sort of get spoiled and we're in our own little bubble a little bit. And still, what comes back from the customer base is it's quite easy, in fact, to build an agent which gives a great demo and is at, let's say, the beta phase, or the prototyping phase. I think there's a lot of promising prototypes. I would also tell you, though, folks are finding it quite difficult to get that agent to be kind of quote production ready. There's a lot of edge cases. There's still a lot of uncertainty about like agent identity, for example. I know this agent in theory is just a digital human, and therefore is subject to the same permissioning that a human would be subject to. But the power of this agent is potentially an order of magnitude greater than a human, because it doesn't sleep, and it can methodically, look at a system or a set of documents, and it could find things potentially that a human could never find. So what I've seen, at least, is a a lot of hesitancy about is this ready for prime time, and have I covered all the edge cases to make this a production offering versus a great demo, number one. And number two, there are still some areas of great uncertainty around security. Even if an agent has got the same security credentials as a human, there's still uncertainty about what it may be able to discover or find or get access to, that a human maybe never would, because we're fallible as humans, and we have to sleep, and we're not methodical, and so on and so forth.
If we look at your approach, you did touch upon that, but since we have gone through this bottleneck, how is your unified approach of data plus observability enable new ways to address those scale and complexity challenges that we are not even being able to fathom ourselves?
Yeah, I think when we first started out several years ago, we felt that observability needed a new architecture. Most tooling was built on a bespoke platform, sort of custom built for logs or custom built for time series. And we were the first to really build for one of these new data platforms, Snowflake. And we felt that the architecture of these new data platforms offered many advantages. They used the cheapest storage you could find, S3. That's a big benefit given the data volumes. Snowflake was quite unique in that it was not an index-based query engine. And so when you ingest data, you didn't have to build these huge indexes. It was a scan-based query engine. Also, I would tell you the separation of storage and compute. You can apply compute elastically to a problem depending on the query complexity. So those were some of the things which made us feel like, maybe a commercial data platform with a new architecture is going to equip us for a new generation at a completely different scale. And as we sit today, I mean, we do about close on 300 million queries a day. We ingest a couple of petabytes of data a day. And in our mind, at least, we've proven that we can operate at the kind of scale that today's workloads demand. I would also tell you, though, back on what I said earlier, if you look at the volume of code we're generating, I mean, things like Claude Code, Codex, most of the code that is going to go into production over the next few years is not going to be written by a human. It's going to be written by an agent, and there's going to be a lot more of it, which means there's going to be a lot more telemetry, which means that, in theory, there's going to be a lot more cost. And we feel like we can keep that cost per gigabyte decreasing as data volumes increase because of the architecture of the platform. And, we should benefit now. Now Observe is part of Snowflake. We obviously benefit from owning the data platform, and we can start to do more vertical integration and optimizing Snowflake better for our workload. So I'll make a bold statement. I think, 5 years from now, I feel like the only credible observability platforms will be ones that are in control of their own data platform, and are operating at scale, because I think it's the only way you can get the unit economics to work.
I will check back with you in 5 years, though I don't actually feel, because what these technologies have showed us, that things are moving so fast. We don't even know what will be there in one. I mean, when the MCP came and so OpenClaw came, so we don't know how things will look like in 5 years.
We know there'll be more queries, though. I think what we do know, like agents can execute more queries than a human could ever imagine. We know that if coding agents are generating code, they're going to generate more code than we can ever imagine. So if you like, our axis of reasoning, and this is where I think Observe has been a little bit different from the rest, is we never really set out to build a tool. We set out to build something which would solve the data problem, ingest the data, get the data in the right shape. And once you ingest the data and you get it in the right shape, then you can quickly and efficiently query it. And yes, we have a user interface that the user would interact with, but I would tell you again, another prediction in a few years' time is that most of the users who use Observe will never log in. They're gonna query their observability data from Cursor or from Claude Code or from their development environment or from GPT, and they're going to use MCP or CLI plus skills, and most of the queries are going to come through sort of a headless observe, and so what's key in that scenario is that we have the most accurate queries, that we have the fastest, and that we have the most cost efficient. And so we're very focused on, and we think that's a data problem. So that's sort of where we're dedicating our time and effort.
Now, if you just look at the traditional or classic observability, I think the idea was around predictability, right? And when you're also talking about AI generated code, first of all, we have to evaluate whether the code is actually doing what we wanted it to do, right? We have to evaluate. Now, in when the code is written mostly by agents, uh, that whole thing around predictability, what code is doing, that also changes. So what is the new norm or normal for observability platform to even look at? Because this is not same that we used to do with humans.
Yeah, I think there's a couple of things we touched on one earlier, but certainly the good thing with the observability tooling, you can now, I mentioned earlier, like with the sort of headless tooling, I can get access to observed data through an MCP server. I can pull telemetry back, and then I can say, hey, here's an error I found in production, a 500 error, or here's some error in the logging. Hey, coding agent, go find me the offending lines of code. Explain to me what that code does, and hey, why not go ahead and suggest a PR for me? So the bad news is you've got more code than you ever thought possible, and you've got more telemetry than you ever thought possible. The good news is it's never been easier to query that data. And actually, you can have the code that generated the telemetry alongside the telemetry itself. So that's almost a nirvana state. And we're starting to see these amazing workflows where developers are saying, hey, go pull that Jira for me. Look at go investigate what's in that Jira with Observe, and then go examine the code and explain to me the code that is responsible. And these are workflows that would have seemed like rocket science just a year ago, but are actually very real today. The second thing I'd tell you is what I touched on earlier, which is it's not enough to just know like whether something's broken or why something is broken. And that's typically what observability has been for the last decade is tell me why. Monitoring was what's broken. Observability was why did it break? There is definitely something now around explain to me the response that the system is giving. It's not broken, right? It's not a failure condition. It's not an error condition, but explain to me why this response is different to what it was yesterday. And help me understand why that response is different. Is there a different prompt? Is there different context been given? And so some of these issues that we're going to see in production are just a lot more subtle. It's not an obvious 500 error from an API. It's not even something's broken in the user journey. It could just be a subtlety in the way that an LLM is responding based on a different prompt or a different amount of context. And so we've now got to get into that, which is a whole new area.
Yeah, it's shifting more toward explainability. Now, as you rightly also earlier mentioned that, Snowflake is fundamentally a data platform. How does that DNA shape your observability thesis? And is there a kind of genuine architectural advantage here, or is it kind of the convergence that is going on in the market right now, which is still has to prove itself, or you're like, hey, this is where things are heading?
Yeah, I think a couple of things which we believe that sort of reaffirmed our view that we'd be better off as a part of Snowflake. I think for the last decade, you've had companies like Datadog and Dynatrace and so on. They've been gradually building out almost like a walled garden. It's a highly curated set of user interfaces which automate the developer's troubleshooting workflow. And it started quite narrow with, let's say, monitoring, and it expanded to logs and traces. And then, hey, let's take a look at pipelines. Let's take a look at feature flags. Let's take a look at RUM. And so it's gradually expanded, but it's revolved around this quite sort of tightly coupled and highly curated user interface. And our sense was like, okay, that I think is going to get blown apart. I back on what I said earlier, I think a lot of the users, particularly software engineers, they're not going to learn a tool. They're not going to learn a highly curated interface where I click my way through, the troubleshooting flow. They're going to demand certain telemetry. They're going to demand certain insights, and those insights are going to be served up dynamically to the software engineer wherever they may be, in Cursor or in code or GPT or wherever. And so the sort of walled garden, highly curated interface we think has been blown apart. And so what you're left with then is the data. You need the volume of telemetry, but you also need context, right? I think the idea that, if you're trying to find a needle in a haystack, well, if you've got 100 terabytes of data a day, rough and tough a petabyte a week, it's kind of hard to find the needle. And so if you can curate that data, if you can provide context, then maybe you're not searching through 100 terabytes for the data. Maybe you're searching through a few gigabytes. And so we felt the crux of the problem with observability increasingly was going to be a data issue. It was about managing the large data volume. It was about curating it and providing context for it. And then it was about the economics. How much is it costing me to do all of this? And that's really what led us to think, okay, if we were a part of Snowflake, we could hugely optimize Snowflake for our workload. We could do way more vertical integration. We could get really industry-leading economics. And then we could transform this data so that we could provide really great context to the array of agents that were now querying it. If we provide more context to the agent, then they're going to find the problem more quickly. So I guess, yeah, our core belief was that increasingly observability was going to become a data problem and not about creating like a highly curated UI that would sort of guide the developer through a troubleshooting workflow. We think that's going to change dramatically in the next few years.
What kind of feedback or reaction you are getting from customers when you talk about the unified approach? How much have you exposed it to them?
Yeah, so what we tended to focus on the larger organizations. We realized a few years ago that there were many observability tools, and if you didn't have a certain amount of data and a certain amount of complexity in your application, then you actually didn't need a lot of the power and flexibility that Observe would provide. And so we've tended to focus on large organizations. We think that in those organizations, they feel the pain firsthand of having many silos of data. So they've got their data for their time series data in a very different place than they do their tracing. They've got several different logging environments, and they've got quite a separate silo, probably emerging around just looking at the data from LLMs. And so the idea that you can bring this data together, is compelling, because when they get into troubleshooting, they see the disconnects and the inability to correlate data. The nice thing about observability is that people historically have not kept data for more than a few days because it was so expensive. So there's no data migration. And I would also tell you with the larger organizations, what is becoming quite compelling is maybe not ingesting data into like a proprietary observed data store, but ingesting it into an S3 bucket and having the telemetry stored in Iceberg tables. And, for the longest time, I think in the observability world, folks have felt locked in because they had a proprietary agent and that would send data to a proprietary data store. And I think that whole world is changing. I think open telemetry is going to be the collector. It's going to send data into, maybe the customer's S3 bucket with an Iceberg based data structure, and then observe, or for that matter, any Iceberg compatible query engine is going to be layered on top of that. So I think it's quite compelling to put the data in one place, to store it in an open format, and be able to query it with something that supports that sort of open Iceberg table format. The second thing I tell you is there are companies that really like the idea of Observe's AI SRE sitting on top of that data and helping people troubleshoot. But I would also tell you that the larger organizations, I think right now, are probably even more enamored with the sort of headless AI SRE. Give me the MCP server or give me the CLI plus skills and allow me to plug in observed data to my broader incident management workflow. And I think a lot of the larger enterprises are thinking of constructing that larger enterprise workflow themselves. So that's sort of maybe the initial feedback, the Iceberg back end and then the AI front end. And, people are thinking about the front end slightly different depending on their size.
Jeremy, thank you so much. It was genuinely very, very insightful discussion. Thank you so much. And also thank for sharing a lot of additional insights that will help organizations as well. This is once again, we'll see how things shape up because we are going through this phase of new technologies emerging, which will force us to rethink how we look at observability. So we will see how things look like in 5 months. I won't wait for 5 years. Things will change by 5 years, and I sit down there. But I really appreciate your time today. Thank you, and I look forward to chatting with you again.
All right, thank you. Have a great rest of the week.